Radian measure. Here's the definition for radian measure. Take a circle of any size centered at 0, 0, and then draw your angle in standard position. So let's draw a picture of an angle in standard position. Here's the initial side, here's the terminal side, here's the rotation arrow. Why don't we call this angle theta? I'm going to call the radius of the circle r. That would be from here to here. And then notice that the angle has essentially cut off a portion of the circle. We call that an arc of the circle. I'm going to call that length S. Well, the definition of the radian measure of this angle is simply the ratio of the arc length to the radius. Divide those two numbers, and that's how many radians this angle measures. You say, well, that's nice, but how in the world am I going to find the length of this curved side? And that's exactly the difficulty, which is why what we really need to do is find a connection to degrees. If we can link somehow this radian definition to what we already know about degrees, we'll be able to understand radian measure a lot better. So on this second picture, let's take the angle theta equals 360 degrees. If I draw that in standard position, it's pretty simple, isn't it? Because the terminal side lies at the same spot as the initial side. It's one full revolution. And in terms of the arc cut off, well, if I go around all the way, then I've essentially cut off the entire circle. In other words, in this example, the arc length is the same as the circumference of the circle, the distance all the way around the edge. Well, you might remember from geometry that there's a formula for the circumference of any circle, namely, it's 2 times pi times the radius of the circle. Again, here's the radius of that circle. Well, when I apply my definition of radian measure, which is S divided by R. S is now the circumference, which is 2 pi r, divided by R. Notice the r's divide out, leaving me with 2 pi. We have come up with a very significant result here, namely that the angle 360 degrees is the same thing as the angle 2 pi radians. I should mention the odd fact that radians are essentially a unitless measurement. And what I mean by that, since we formed a ratio here, let's say this had been in inches, S inches, and this had been in inches, R inches, then the inches units themselves would have canceled out, leaving me with no units at all. Because of that, the word radians is not even typically written. It's understood, it helps us communicate an idea, but typically we just write 360 degrees equals 2 pi, understanding that the 2 pi represents radian measurement of the angle. This is a huge relationship. It's certainly one you want to memorize and know. Maybe even more importantly, though, is the measurement that comes if I divide both sides here by 2. After all, if a full rotation of 360 degrees is 2 pi radians, then of course a half rotation of 180 degrees would be equal to 1 pi, or just pi radians. This is the one I think that comes up the most and will help us in terms of going back and forth between degree measurement and radian measurement. So you want to know that one well. 180 degrees equals pi radians. So which one is bigger? An angle that measures 1 degree or an angle that measures 1 radian? Well, it's not too difficult to think this one through. If it takes 360 degrees to get all the way around a circle, then a degree must be pretty tiny. I mean, after all, it takes 180 to get to here, 90 to get to here. 1 degree would be 1/90th of that little quarter turn there. It's so small that it's really hard to draw. I'm sure that's even too big, but 1 degree would be very, very small. On the other hand, 1 radian, well, let's see, how many radians does it take to go all the way around the circle? We just learned that to be 2 pi. Pi, you remember, is around 3.14, so 2 times that amount would be around 6.28. Pi is just a number. It takes about 6.28 radians to make it all the way around the circle. So that means 1 radian must be somewhat large, maybe something like this. And then if I did a little more than 6 of those rotations, I'd make it all the way around the circle. So 1 radian is definitely a lot bigger than 1 degree. Thanks for watching.